Welcome. Today we discuss the chapter limit and continuity. So first of all, I mention the standard formula of limit. I think all of you know it. Still, I am discussing it. But very few of them I discuss. Number one, limit x tends to a x to the power n minus a to the power n by x minus a, it is n a to the power n minus 1. Next, limit x tends to 0 sine mx by mx, it is equal to 1. Here m is any real constant and x is expressed in terms of radian, not in degree. X in terms of radian and m is any real number. Next, limit x tends to 0 sine inverse x by x is equal to 1. Limit x tends to 0 e to the power mx minus 1 by mx is equal to 1 for all real m. Limit x tends to 0 a to the power x minus 1 by x is equal to log a base e. Next, limit x tends to 0 1 plus mx to the power 1 by mx is equal to e. Limit x tends to infinity 1 plus 1 by mx whole to the power mx is equal to e. Okay. Besides using that, we can use for evaluating limit L'Hospital rule. What is that? Suppose, I think all of you know it, still I am mentioning. Suppose a function is of that type fx by gx. Now, limit, we have to calculate limit x tends to a is any finite number, fx by gx. If by putting x is equal to a over here, that is fa and ga, if this is of the type 0 by 0, that is in numerator its value fa is 0, in denominator ga is 0, then only L'Hospital rule L is applicable. What is that? Now we have to find simply derivative of the numerator only, f dash x by derivative of the denominator g dash x, limit x tending to a. If it is not of the type 0 by 0, then its answer is f dash a by g dash a, whatever be the value. But if again this is f dash a is 0, g dash a is again 0, that is it is again of the type 0 by 0, then continue the process. When ultimately we get that it will be 0 by 0 not of that form. In that case, we can very easily find the limit. The continuity of a function at any point. If fx is equal to y is equal to fx, by fx is equal to, say fx is a function and x is equal to a is a point. If the limit of that is limit x tends to a fx is equal to fa, the functional value of it at the point x is equal to a. If this is equal to that is ultimately left hand limit of fx, right hand limit of fx and fa, three are equal. In that case, we say that the function is continuous at the point x is equal to a. So, say left hand limit at x is equal to a, left hand limit is equal to right hand limit is equal to fa, then only we can say that the function is continuous at the point x is equal to a. If the function is fx is continuous, say in the interval a less than or equal to x less than or equal to b, continuous at all points within this interval, then we say that function is continuous within the interval. Okay, then about I tell you few functions which is continuous. Number one, all algebraic function having no denominator, all algebraic function having no denominator is continuous everywhere. Number two, suppose a function is of that type fx by gx, that is it has denominator. If the denominator is non-zero at a point, then it is continuous function. Even if gx is non-zero on that interval, say is non-zero, then function is continuous over that interval. Sin x, cos x is continuous everywhere. Tan x is continuous everywhere except where it attains infinity. Same is cot x. Actually, the function, if a function is not finite, is finite and real, then we can say that the function is continuous over the interval. The mod function mod x is continuous everywhere. Mod of x minus a is continuous at the point a and everywhere continuous. Exponential function is continuous everywhere. Log x any base a is continuous for x is greater than 0. Continuous everywhere. So you have to keep in mind all these things, all these functions which are continuous, then it will help you a lot. Now we shall take few examples. First example is limit x tends to 0 cos 2x minus e to the power 3x by x. Find the limiting value of that. Options are 2, 3, -3 and 1. Using formula or using L'Hospital rule, in both way I solve it. First of all, using formula, it is equal to limit x tending to 0 cos 2x minus 1 minus 1 minus actually plus 1 minus e to the power 3x. Actually, I have taken minus 1 and plus 1, they balance, divided by x. First part is cos 2x minus 1 by x plus limit x tends to 0 1 minus e to the power 3x by x. Second part. Now it is actually equal to limit x tending to 0 cos 2x minus 1, it is equal to minus 2 sine square x divided by, this is minus 2 sine square x by x plus limit x tending to 0. This has a formula, 1 minus e to the power mx by mx. If it is by mx, then balance. It is equal to actually limit x tending to 0 minus 2 into sine x by x into sine x plus 3 into, it is limit x tending to 0 1 minus e to the power 3x by 3x. It has a formula which is simply equal to 1. For this case, sine mx by mx, sine x by x 1, but this is x tending to 0, so this is simply 0. So minus 2 into 1 into 0, so that it is equal to 0 plus 3. So answer is 3. This is correct option. Now this can be done, I think, more easily by using L'Hospital rule, L'Hospital rule. What is, how to apply it? I told you, if by putting x is equal to 0, numerator become cos 2 into 0 means cos 0 is 1, e to the power 0 is 1. So 1 minus 1 is 0 by x is 0. So that it is of the form 0 by 0. So we can say L'Hospital rule is applicable. What is that? We have to differentiate the numerator. It is minus 2 sine 2x, derivative of the numerator, minus 3 into e to the power 3x by derivative of the denominator is 1, limit x tends to 0. Now by putting x tends to 0, this not 0, this is not 0, so it is not of the form 0 by 0. Now by putting x is equal to 0 over there, we get the answer. It is equal to limit minus 2 into sine 2x minus limit x tends to 0, 3 into e to the power 3x. Now put x is equal to 0, this is minus 2 into 0 minus 3 into 1. So that minus 3 answer. This is minus 3 answer. Oh, wait a minute. This is minus 3. That is okay. And in first type, we get it is cos 2x minus 1 minus e to the power 3x minus 1 by x. This is plus 1, this is okay. Cos 2x minus 1 by x, limit extending to 0, it is there, minus limit extending to 0. So e to the power 3x minus 1 by x. Its value is that. So 3. Oh, minus 3 is there. Actually, this minus is there. So in first case, the answer was minus 3. Second case also, same answer must be obtained. So answer is minus 3. Sorry. The next problem. The problem is limit x tends to a root over of 1 minus cos of 2 into x minus a divided by x minus a. Limiting value of that. You can options are a 1 minus 1 does not exist. For better understanding, let us take x minus a is equal to y. So as x tends to a, y tends to 0. So this becomes limit y tends to 0 root over of 1 minus cos 2y by y. It is equal to limit y tends to 0. This is root over of 2 sine square y divided by y. Now you see y tends to 0. When y tends to 0 plus, that is right hand limit, then y is positive. But when y tends to 0 minus, that is left hand limit, value of y is negative. So simply sin y, it is a negative quantity in that case. So that it is equal to root 2 into limit y tends to 0 root over sine square y by y. So its left hand limit root 2 into limit y tends to 0 minus sin y is negative itself, so that it is equal to minus sin y by y, so that its value is minus 1. Its right hand limit root 2 into limit y tends to 0 plus. In that case, sin y itself is positive. So its root over is sin y by y, it is plus 1. So left hand limit minus 1, right hand limit plus 1, so that limit does not exist. So that this is correct option. Our next problem, limit x tends to 1, root over of 4 minus x square minus root 3 divided by x. If in a problem of limit, it x tends to 0, sorry. If by putting x is equal to a, in this case a is equal to 0, if you put it there, no, I think, oh, the problem is not that. Tends to 1, numerator is okay, denominator is root x minus 1. Now if we put x is equal to 1, this is root 3, this is root 3, so 0 in numerator. This is 1, this is 1, 0. So it is of the form 0 by 0. So we cannot get answer by putting x is equal to a. Achha. If it is of the form 0 by 0 and there is some radical sign, square root, cube root, etc. First of all, we have to remove this sign, square root, etc. For that purpose, multiply throughout by conjugate of this and conjugate of that, numerator and denominator. So it is equal to limit x tends to 1, root over of 4 minus x square minus root 3. Now multiply by its conjugate, 4 minus x square plus root 3 divided by this one first, root over of 4 minus x square plus root 3. So this balances. It is root over of x minus 1 multiplied by its conjugate. For balancing this, multiply this also by root x plus 1. So that ultimately we get limit x tends to 1, they together is 4 minus x square minus 3. This and that multiplied by this, root over of x plus 1. By root over of 4 minus x square plus 3, they together is x minus 1 is equal to limit x tends to 1. This is 1 minus x square, they together. 1 minus x into 1 plus x into root over of x plus 1 by root over of 4 minus x square plus 3 into x minus 1. Now this x minus 1 and 1 minus x will be cancelled with a negative sign, so that it is equal to minus limit x tends to 1. This cancels with that 1 plus x into root over x plus 1 by root over of 4 minus x square plus 3. X minus 1 cancels. Now put x is equal to 1, so that it is equal to minus, they together is 2 into, they together is 2 by root 3. Oh, I have mistaken. This is always root 3. This is root 3. This is root 3. This is root 3. And now this is equal to actually root 3 plus root 3, 2 into root 3. So that the 2 cancels, minus 2 by root 3. So I have not given you the options. Actually, minus 2 by root 3 is one of the options. So this is correct answer. Next. Limit x tends to 0, 1 plus 3x whole to the power x plus 2 by x. This can be written as limit x tends to 0, 1 plus 3x whole to the power 1 plus 2 by x is equal to limit x tends to 0, 1 plus 3x whole to the power 1 into limit x tends to 0, 1 plus 3x whole to the power 2 by x. Oh, option again I have forgotten to give you the options. Options are e to the power 6, e to the power 3, e to the power 1 by 3 and e to the power minus 1. These are the options. The first part, it is limit x tends to 0, 1 plus 3x. This is simply 1 plus 0, 1 into limit x tends to 0, 1 plus 3x to the power something. Now 1 plus mx, if it is 1 plus mx, now of this type x tends to 0, 1 plus mx to the power 1 by x. So I write it 3x. Now adjust. Actually it was 2 by x, so it is 6. If it is 6, this is 2 by x. Now this is equal to limit x tends to 0, 1 plus 3x whole to the power 1 by 3x whole to the power 6. Limiting value of this is of that type, 1 plus mx whole to the power 1 by mx, it is e. So e to the power 6 is correct out. So this is answer. Okay. We discuss few more problems on next day. Thank you.